Let's go with the flow. Joe. Flow, Joe. Let's say all the words that rhyme with Joe.
That's a lot.
Hey, Mo. Shape, size, design. How did you get from 1266 to Diana? Yeah, that's a stretch.
Well, it wasn't an evolution, that's for sure.
No, I don't think we would call it an evolution.
No. So there's a lot to this one.
Well, first of all, Diana's a female, so she had to look different. In a lot of species, the females are smaller than the males.
It's true. Right.
So that's one thing.
So from an outward perspective, most people would say, oh, 1266 to Diana, it seems like a totally different headphone, right? How could one company design both because they're so radically different?
Yeah.
And in some regards, both are quite different than what you see on the market, right? In the similar type of feature set and whatnot, they're pretty unusual. From our perspective, I would say that they both have the same design philosophy. Because with 1266, the whole goal was to make a high performance, no compromise headphone that performs as well as we know how. And Diana, it was designed to get as much performance as we could get into a small, light, portable package. So it's obviously much smaller, much lighter, totally different, more conventional fit, and a little bit lower price points. More of the things you expect in like a traditional type of headphone, but as much performance as we could pack in that type of shell.
What do you remember going that way?
It was just like, how are we gonna fit all this into this little box?
Yeah.
It's like
That was the biggest
it
issue.
just every single thing was a problem because coming from such a big headphone,
Yeah.
it was like space was like not at a
space
premium.
for
You're like,
days.
yeah, we could just whatever.
Yeah.
But then in the Diana, like every millimeter counted.
Yeah. Well, the whole philosophy was to get her to be the thinnest planar magnetic on the planet. You know what I mean? At least in terms of the high end. I mean, anyone could mold a plastic piece thin and throw a speaker in it. That's simple. But yeah, to make a planar this small was unprecedented. So I think part of the reason we did it is because no one else did. It didn't exist.
Yeah, that makes sense, right?
Yeah. There was nothing like it. I mean, I think we've had some reviewers caught onto that too, that there's nothing like this on the market.
Why would you build something like someone else?
Yeah, exactly.
You could buy it from
That's
another
boring.
company. Why would we make one
Yeah.
just like that?
Yeah, copying things isn't really fun.
Yeah.
Not at all.
Yeah, but Diana, basically the goal was to make as much performance, basically the same driver as 1266 in a small, thin shell. So it was a very different objective from 1266. 1266 is what do we need to do to get the performance that we need. Diana is how can we make this driver work in a really tiny chassis.
Yeah, acoustically, fit-wise, connection-wise, had to figure out a way to connect the cable without having things fall apart on you over time.
Yeah.
That was a challenge to recess that jack inside of Diana. The body, the plug goes in Diana. We had a custom mold made for the plug, so the plug would survive a fall and impact, no problem.
Yeah, I'm pretty happy with that one.
Yeah, it came out
A lot
really
of people
good.
complained initially when we first released Diana saying, oh, 2.5 millimeter,
Yeah.
it's gonna break. Because apparently other manufacturers have used it and they had issues.
Yeah, right.
But they had a very different design.
Yeah, we tend to get pinned a lot with problems
kind
that
of stuff,
other people have had. Yeah,
right.
We don't have the same issues.
People say, oh, well,
Yeah.
don't you know somebody else already tried it and it didn't work?
Yeah,
Well,
that doesn't mean they did it the right way.
apparently they didn't because
No.
we haven't had a single connector failure on Diana.
No, the connector is robust.
Even with people with aftermarket cables that aren't using the strain relief in the frame, they got like this dump truck cable, huge
Which we don't
thing.
recommend, by the way.
Not a great
I don't
idea.
like seeing that kind of stuff,
but-
hanging speaker cable off of a Diana.
So far, nobody broke a jack doing that, so
No.
that's good.
Yeah. Well, we purposely made the hole small enough where you couldn't fit much in there.
Yeah.
We said, look, if you're going to use you got to use the right connector. And
Well, people
the
are
smallest
using like the
connector-
extension ones for
Yeah,
like
yeah,
the original iPhone.
Yeah, that's true, like an adapter.
So they don't touch the
those
body
aren't
at all.
that good then.
It's okay,
Yeah.
but it's not ideal.
Not a really good idea.
Yeah.
That's right, because they sell those connectors with the extensions too.
Yeah.
Yeah. But no, that was a big problem. Remember you were talking about fitting everything in there like that jack
Oh
alone.
yeah. Yeah, the jack is actually the limiting factor of the thickness of Diana.
Yeah, right.
If it wasn't there, if it was hardwired, it could be thinner.
Yeah, we reached
Yeah.
a point where there was no more space even for a jack.
Yeah.
It's
And
why
that-
Apple got rid of the jack in the phones.
Well,
You know?
well, they had to make their own. The Lightning
Yeah.
is thinner.
All right. But they got rid of the, 3.5 millimeter.
Well, yeah.
That would have been huge. I mean,
Well-
we couldn't barely fit the 2.5 millimeter in this.
Yeah.
We couldn't
Imagine
fit.
fitting a 3.5 millimeter
Yeah,
in
the
it?
It
three and a
wouldn't fit.
half.
In a
It would have
phone?
to be a bigger housing.
Yeah.
But even on 1266, the mini XLR we have on there,
Yeah.
that's the same thickness as the housing. That's the
Yeah.
limiting factor.
No, that's
on
true.
1266.
Yeah, we
Yeah.
probably could have
Right.
thinned that out a little bit, but that jack
Right,
is
but
big.
the jack's as big as it.
Yeah.
There's
I
not
tried
much
to
there.
get you to make that one a little thinner, but you're like, you wanted a lot of material around that jack.
It's
Yeah.
about as thin as you
It
can get.
is
Yeah.
about as thin as it can be.
Yeah. We wanted the mass too, a little bit more mass there where the plug entered, so absorb some vibration from the cable, anything that came up through.
But back to the question.
Yeah.
I understand why somebody would ask something like that. That's a very reasonable question, I think. But from our perspective, it seems intrinsically obvious because Diana and 1266, although they look very dissimilar from one another, they both have the same approach. It's we don't care what anybody else is doing. The goal is to make what we think is the best thing possible. As
Yeah.
long as it's a compelling product, we'll offer it, right?
Yeah.
Well, I think that's the biggest thing is Diana, while being thinner and lighter, we didn't sacrifice strength. The best way to put it would be it was the closest to evolution from 1266 compared to the exterior, the
Yeah.
driver. That it was an evolution. It wasn't revolution like
Yeah.
the Diana itself, the frame and
Right.
everything, because it's pretty similar. I mean, it had to be changed a little bit.
I guess there was some evolution involved with the driver.
Yeah.
Yeah, because we had to modify the driver to fit in Diana.
Mhm.
It's a 1266 Phi driver in the Diana Phi.
Mhm.
And yeah, we had to, that was a trick in itself. Most of the components changed except for the magnet structure, right? Then we changed the,
Everything
Mhm.
changed pretty
Yeah.
much. So it's the
I
same.
mean, it's a similar driver, but
Yeah.
same materials.
It's effectively the
but
same driver, but
shrunk it down a few
yeah,
millimeters.
a lot of accommodations had to be made to get it in the housing,
Yeah.
Yeah.
to get the electrical contacts, to bring the dimensions down so that it physically fits. So the things that were deemed frivolous or unnecessary were adjusted or moved to be able to accommodate Diana's housing.
We improved on the temperature coefficients too, where the thing can handle cold outdoors more than
Yeah,
the big 1266, you know. In fact, the TC now is
right.
Yeah.
integrated that too.
Yep.
So yeah, there's all kinds of things. There was evolution going on in the
Mhm.
driver, and too how the connections, how we make connections, the everything really. We did a lot of change to integrate that driver into a form factor that small.
Yeah, there's a surprising amount of things now that I think back.
Yeah.
Mhm.
Because even something like the slider, remember the first sliders we were making?
Yeah.
The
Yes.
headband
Behind-
adjustments.
Yeah, so
Yeah.
the thing that
We call
holds the
them sliders.
headband.
Yeah.
Yeah, the thing that adjusts the height on the headphone for
Right.
Diana.
Yeah.
That went through 20, 30 revisions
Oh,
or something
geez.
like
Yeah.
that.
Yeah.
But initially it was made out of 6061 aluminum. And
Oh, right.
to get it to where it needed to be to function, it was too weak.
Mm.
And so it needed to get thicker or stronger material needed to be
Yeah, we had
used.
to switch alloys up.
Right, and
Yeah.
I didn't want to make it thicker, so we ended up using 7000 series aluminum,
Yeah.
which is considerably more rigid in that assembly.
Yeah.
Mhm.
But it solved the problem and didn't have to get thicker or heavier,
Yeah.
which is nice. But there's a lot of things like that, like
Yeah.
little fiddly things that considerably
Yeah, where you're
increase
thinning
cost and
everything out so
complexity.
thin but you don't want a weak structure.
Right.
You don't want a customer to be able to, no matter what they're going to do to this
Right.
thing,
Yeah.
ruin the structure.
Yeah.
You know? So,
You got to be
yeah.
able to abuse it a bit and still not have it fall apart on you.
Yeah. You also can't have much flex on the driver or anything like that when you're grabbing it or whatever.
Yeah.
So the front by the steel baffles were set up a certain way to stiffen the driver assembly and stuff like that.
Yeah.
And,
Mhm.
It's a very similar design language to 1266. It looks very different outwardly, but inwardly, of course, the driver is basically the same thing
Yeah.
with tweaks and revisions, and it actually was minor improvements that trickled back down to
Trickled up.
it's trickled up
Yeah.
to 1266
Did it
TC.
trickle up?
Yeah.
Yeah, however that worked.
Yeah.
yeah. Well, if you're standing on your head, maybe it's up.
Right.
Yeah.
But there was things out of necessity that we had to do on Diana to make it
Mhm.
work.
In fact, maybe the engineer was standing on his head when he designed this thing.
Mm.
It could have been, yeah,
Maybe
Well-
you're schizophrenic. I don't know.
probably.
Yeah, maybe another personality said, "Make a small headphone, thin, really thin." No,
Mhm.
actually, I think it was me that started that.
It might-
Yeah, it was. It was.
Okay, so I'm schizophrenic.
Well,
no, actually, I don't hear voices or anything, and no one's. Well, I
You
shouldn't
sure?
say that. Yeah, I don't hear. I don't have multiple voices in my head.
Mm.
I might hear voices, but they ain't coming from me.
Oh.
Okay.
But anyway, that's a whole different story.
I mean, making both of them,
Yeah.
to me, they're like no different, you know.
Yeah.
Physically making the drivers, you know.
Yeah.
But yeah, I could see how.
You mean in terms of
yeah,
assembly?
Yeah, yeah. Like physically assembling.
They're
the
done in
driver.
the same way.
Everything's done the same.
The parts
All the
are
parts are
different,
just slightly
yeah.
different.
Right. Yeah. Well, now they are.
Yeah.
Yeah. Now that we have TC and the Phi and
Yeah.
even the V2 is a similar assembly, just different materials.
Yeah.
A little different driver materials and stuff like that.
Yeah.
And, really the difference between the 1266 and Diana Phi is more of an acoustic.
Yeah.
I mean, yeah, it's smaller, thinner, and that's part of the acoustic. There's not as much space.
The pads.
The ear pads are way thinner and smaller relative to the 1266, which is some of the bigger pads on the market.
Yeah.
I mean, they're over 4 inches outside diameter on
Right.
1266 pads.
If you had
know?
basically the same pad on Diana with no mesh in front of it,
Oh,
no
don't
holes
say
to
that.
mesh
Now
it in.
people are going to want us to do that.
yeah,
Can you make an ear pad as big as a 1266?
It's
No, it
basically
won't
the same
fit.
thing, but yeah.
It won't fit.
It's bigger than the
Yeah,
Diana.
full out. I don't think you can make it work, but someone else can try that.
You can do what you want.
Well,
But yeah, you're right. It would add some depth. It would add a little bit of depth. Probably
It would
to
be
the-
basically the same thing.
yeah. The
Yeah.
only difference is the no foamed aluminum.
Yeah, the backside
Right.
still isn't quite as open as can be
Right.
relative to that crazy aerospace foamed
Yeah.
aluminum we use on the 1266. You made the holes as big as you could as the openings in the Fibonacci pattern. We tried to set up the best acoustic we could for the driver with that design, with a
Yeah.
machining it all one piece of aluminum for the
Mhm.
shell of Diana.
Yeah.
So
The
came out
3D
really
structure
good.
on the foamed aluminum for a 1266, definitely superior for that, but integrating that is a challenge.
Mhm.
Yeah, that wouldn't work in her, and
Yeah.
it's not. It's just once again, it would stray away from the design philosophy. It was let's
Right.
thin this thing out and make it as. So I mean, really, the concept was when you see people wearing headphones, they're always chunky, bulky. You look at headphones. You rarely see headphones advertised on people's heads
Mm.
because they don't look that good. They look better standing
Yeah.
on their own.
That's a strange
Look
point
at the
there.
way
'Cause
anyone makes any photography. They
for
rarely-
whatever reason, with headphones, they're always advertised standalone on a table,
Yeah.
on a headphone shelf rack
Yeah.
hanger thing or something like
They
that.
never look sexy on people. Really, they
And
really don't.
They don't show them on people's heads.
Yeah. So the idea with Diana was when you wear her, it was form fitting. It was going to be where you could barely look in it from a distance. You could barely tell the person had a headphone on. That's kind of cool to me. I think that's the opposite. Everyone else just chunks it out. I'm starting to see in the marketplace, not in the high end, but we'll see even in the high end, some attempts at making things thinner. You're starting to see it a little bit here and there, but not to this level.
Hmm.
There
Because
seems to be a
it's
little bit more
challenge.
thought put into it. But yeah, it's
Yeah.
significantly more challenging. It's
Yeah.
way easier to make a headphone just gigantic.
Yeah,
Mm.
yeah. Just throw in there what you need and you're done.
There pretty much aren't the issues you see with small headphones. If you just make everything bigger, you don't run into a lot of the limitations.
Yeah.
But then everything might either be too big or excessively large or ridiculous looking or something like that.
Not to mention, as you get smaller, the precision involved with every part has to be higher.
Yeah.
You've got to have everything's got to be more precise. You don't have a lot of give or play when everything's tight.
Oh,
When
yeah.
tolerances are so tight. So where bigger or made with plastic, you've got a lot more, region. Or even if things snap together, you got a lot more region for play. But here, we machine just about every part on the damn thing, right? The baffle we make,
Yeah, I remember doing the sliders initially, trying to get the tolerances right between the frame and
Oh
everything.
yeah, right.
And you just got to measure every one.
Yeah, too
you
loose
know?
and it wiggles, and
Yeah.
too tight and it won't.
And
At
just-
some point, it
yeah,
might not slide.
Yeah, it doesn't slide.
Yeah, I mean that's pretty precise. What's the gap between the slider and the side? Do you know?
The design gap is 5
5 thou to either side.
tenths. So 0.0005 inch. Yeah.
The gap between the slider and the
Yeah.
one side. Yeah, the
The
side.
tolerance on the slider is 2 tenths.
Yeah,
Total deviation on width.
yeah,
Yeah. And if it's off, they don't work.
yeah. Right.
You know?
Yeah.
Just doesn't slide in.
Yeah. So I mean that's serious shit.
Yeah.
You got to be.
There was a lot of
Yeah.
trial and error on that
Yeah.
one.
Yeah, I'm sure you machined a lot of sliders to make it work. I remember the prototypes. It's like this one doesn't want to move.
Yeah,
or this one's like wiggling.
Yeah.
It's
Yeah,
like,
it was a learning
somewhere in
experience.
between lies where we
Yeah.
need to be. So, but anyway, the obviously the final product came out really well.
Yeah, we got
And-
it dialed in now.
And that magnetic slider is the coolest thing, man.
I
No
don't
moving
think
parts.
it would be cost effective to manufacture Diana if we had to pay somebody else to make the metal components, the frame assembly.
Oh, it'd be a fortune.
Mm.
The
That
machine
would
time is crazy.
That would at least triple our costs.
I don't know if you have it in your head, but it's probably 2.5 hours or something like that. Isn't it really high machine time for the?
There's a lot of
sides?
holes.
For
Lot
on
of
our
holes.
machine,
I don't know, 700 holes per side that the CNC's got to drill.
Yeah, it's like
848
almost
or something
900.
like that.
Jesus.
Yeah.
Yeah.
per side.
Per side, yeah.
Right, but our machines are optimized for those frames. So it's kind of misleading, but yeah, there's a few hours of machine time in the total frame, but those are highly optimized parts with machines and tooling designed specifically effectively for those parts. So if you were to hand them over to someone else, it's very unlikely that they would put the effort into optimizing those exact
Yeah,
parts.
that would
It would
take
be
weeks.
considerably more machine time.
Yeah, you pay them
And
more to figure out how to get their machine to make it than
Yeah, they
the
wouldn't
parts
do
cost
it.
to
You
make.
would just have a really high cost.
Yeah,
Yeah.
or the part wouldn't come out right.
And the logo's 3D surfaced,
Oh, yeah, right.
which is ridiculous.
Yeah, right. Yeah, nobody does that.
No.
You would mold that out of plastic. You would never machine that.
There was a lot of other ways to do that that are cost
Yeah.
effective, but
Yeah,
there's some elegance to the
that's us. We're crazy like that.
3D machine logo.
The proof is in the pudding. The customers that own Diana, purchased Diana, spent the money on Diana, love it, love her. And, we get great feedback all the time on her.
Well, there's a lot of 1266 owners that have them too.
Well, that's true.
Yeah, some
Yeah.
people buy
They
all
like, well,
three.
Yeah, that's
So
true.
there are a few people with all three.
Yeah, right. One in the office, one at home, and
Yeah.
one to go.
Yeah.
which is awesome. Which seems to say we need more models because then they'll buy a fourth and a fifth.
Yeah.
Anyway, I guess we should wrap this thing up. Here we go again off on a tangent.
Yeah.
So anyway, thank you everyone for watching. Please subscribe. Give us a thumbs up if you like this video, and take care.